You can be seated. Ladies and gentlemen, I hereby open the public meeting of the Examination Committee for Embedded Systems. My name is Johan Lukien. I'm the Dean of the Department of Mathematics and Computer Science. It's a pleasure to welcome you on this, and the candidates, of course, on this graduation event. The Embedded Systems Master Program is a joint program between the Departments of Mathematics and Computer Science on the one hand and Electrical Engineering on the other hand. We are, as departments, proud that 12 of our students, you see them here in the front, will receive the degree of Master of Science today. Actually, there are 3 such meetings, so you can do the math, I think. We're quite proud of this type of day. We offer the students a rich variety of advanced courses given by excellent teachers. They also did a challenging graduation project. And we think they are well prepared for their careers. Some go to industry, some remain in science, maybe some do their own companies. But anyway, I sincerely hope that you enjoyed the time that you spent here the last 2 years of your master. Today, the following candidates will receive their diploma. Sham Boré, Pega Bagramyan, Joshi Chandrika, Yul Dix, Janis Gnavel, Bargav Kinal, Geert Linders, Vinexwar Madreas Elangu, Ruud Meeuwse, Sindhuai Prakash, Aaron Ramachandran and Mike Vermeulen. Ladies and gentlemen, candidates, Master of Science. I'm pleased to say that you have all passed your examinations and will therefore receive your diploma shortly. This entitles you to carry the title Master of Science or the Dutch ingenieur. Next, the graduation advisors of the candidates will hand over the diplomas and, along with a short speech. I will not further introduce them. That will be on the screen above. And with that, I call as the first to receive his diploma, Vineshwar Madras Elango, the first candidate, and his advisor, or the one who gives the speech, Dr. Stuik.
So, dear Vanishkar, I was not actually your advisor, as you know. There was someone else, Dip Goswami, but he actually gave me a speech to read for you. So wherever I say I, you should read his name. First of all, also on behalf of Dip, his hardest congratulations for obtaining this degree. My sincere apologies for not being able to be present in person. You worked at Siux on your master's project. Your company supervisor there was Koen Rutten. I was your supervisor at TUI. Your project was defined as part of a European project, IMEC, which deals with embedded implementations of industrial motion control systems. In particular, your project dealt with image-based motion control of generic substrate carriers. For those of you who don't understand, I have a short explanation. Many modern systems, such as throughput professional printers, lithography machines, require high-precision motion control systems. So those are all kinds of systems developed here in the Eindhoven region. The generic substrate carrier is a setting that is used for achieving high-precision micrometer level accuracy using optical encoders for position sensing in such systems. These devices are error-prone to physical phenomena such as thermal deformation. Furthermore, they are very expensive solutions to deal with the errors to maintain the desired accuracy. What you've done throughout your master project is to develop an alternative technology for position sensing. You used camera and image-based processing to essentially develop a sensor. That combination of camera and processing platform reduced the price of the overall system. The challenge then is to deal with high processing demands and the demands for high accuracy. You've developed a code and decoding technique that allows for low processing position sensing with relatively high error resilience. You have prototyped the solution with real mechanical and electrical components, such as a belt, a camera, processing board, and interfaces. The work was very challenging, given that it involves understanding of the mechanical structure, the embedded system, and programming and coding theory. You've dealt with all of these aspects very systematically and efficiently. You made plans for every single part of the work and worked it out accordingly. In spite of several practical challenges, with the volume of the work and the time frame, you have achieved everything aimed for in this project. Your supervisor at SIUX, Koen Rutten, liked and highly appreciated the work. The proposed technology is now decided to be part of the bigger IMAC European project solution that involves nearly 40 partners all over Europe. Overall, it's a very complete and solid piece of work which has a combination of theory and practice. I, and again that's Dip, found you to be a hardworking and motivated person with lots of energy and enthusiasm. The other point that I would like to point out is that most of your attitude, and I must mention in this occasion that you've never taken shortcuts, while quality is compromised. So you really worked very hard to achieve this solution. In fact, you were more interested to work on an internal project since you were convinced about the topic. Unlike many, you always made choices based on the content and quality of the work you tried to achieve. I congratulate you once more for this achievement and wish you all the best for the future. Kind regards, Dip.
Sean, you come here.
Okay, before I start, I explained why I have 6 speeches in a row. Actually, I haven't supervised all of them. I have 3 master students myself, and my colleague Kees Goossens, he had 3. But we are co-lecturing a course this semester, and this afternoon was his turn to go to the lecture. So he apologized all of you not being able, because of not being able to be here, but he sent his regards and congratulations to you. So, dear Sion, congratulations with your degree. Last summer you asked me, means Kees, if I was willing to supervise your project at Thales in Hengelo. The topic was RF signal analysis using RF system-on-chip technology, which sounded very interesting, so I quickly agreed. Thales makes radar systems amongst many other high-tech products that are very advanced. The goal of the thesis project was to implement parts of the radar on a commercial off-the-shelf FPGA component from Xilinx. Field programmable gate arrays, or FPGAs, are chips that can be programmed as if they were dedicated hardware. This is usually almost as much work as designing a real chip or ASIC. Next to that, recent FPGAs also contain powerful software processors. Finally, the Xilinx RF SoC also contains powerful hardware that is dedicated to signal processing, such as A to D and D to A converters. In essence, the goal of the project was to take a mathematical problem, in particular spectrum analysis, frequency measurement, and direction of arrival estimation, and implement it on the FPGA board. When we met at Thales for our first meeting, I told you and your Thales supervisor that this was impossible in the scope of a master thesis because the algorithm as well as the design flow were too complicated. Moreover, you didn't have a strong background in signal processing in that moment. So, well, you proved me wrong, first case. First, you made an algorithm out of the mathematical problem. This is not easy as an algorithm, as the algorithm has to balance computation time, computation resources, memories, bandwidth, etc. And there was many different options. Second, many of these options are then not easy easily implementable on a given FPGA, which is not always obvious before starting. You explored a number of different algorithms and adopted them accordingly to the possibilities and limitation of both the FPGA hardware platform and design flows. Something that seems trivial, such as giving two chips the same clock signal, turned out to be a major problem to analyze and work around. At the end, you had a combined hardware-software design running real-time that implement almost all of the required mathematical functions. When you started, you first brushed up on the signal processing, the algorithms, and then the Xilinx design flows. During all this, you worked hard and were very organized. Also in the reporting. The end result was impressive given the broad scope and amount of technical work that had to be done. Clearly, this was why Thales offered you a job. So congratulations again, and I wish you the best in your future career at Thales. Okay. Dear Dayanishwara, you're my own student. On this joyful day, I have the honor to give you the master's degree of the Embedded System program. Around 1 year ago, you started your master project at Signify, formerly Philips Lighting, working on performance evaluation and design of Bluetooth Low Energy Zigbee combo networks for lighting control and asset tracking application. So as the title says, the project included two applications, lighting and asset tracking, and two different wireless technologies, the Bluetooth Low Energy and Zigbee. So the wireless devices should support in this work, they should support both technologies, and in an efficient way, they switch to different technologies for different application scenarios, application services. It means that you needed to have a good understanding of both protocol stacks and applications. You had some, as I remember, you had some background and experience with Bluetooth Low Energy, but you gained the knowledge about the other parts quite fast. The project was challenging also because it involved a considerable amount of implementation and experimentation. And you were successful to achieve the goals, and the result of the project are valuable for the company. So the result of your project not only shows your strong background and technical skill, but also your dedication, your spirit of hard working, and the spirit of hard working. It was a real pleasure for me to work with you. To conclude, I would like to congratulate you again and for this achievement, and wish you the best in your life and in your future career. So your work was also supervised by Professor Kees Goossens, and I'm just reading the speech that he sent to me on behalf of him. So maybe I have to. So congratulations with your degree, Jules. In 2016, you contacted me if I was willing to supervise your internship in Rio de Janeiro. On the topic of unmanned aerial vehicles. It was an interesting topic, so I had no hesitation to accept. I'm not quite sure how you picked the PUC university, but I'm sure that Rio, the beach, and the summer period had something to do with it. Anyway, at some point in 2017, you returned and you asked me to be your final project supervisor. Given that you did your internship well, that was not a problem, of course. In the meantime, you started working at ProDrive as system architect for a large project on wireless charging of cars. Technically, this was a challenging project because of the large voltage and current involved, as well as the strong electromagnetic field between the car and the chargers. The hardware and software architecture were very complex, and actually everything to do with cars is quite complicated because car manufacturers have very strict safety and quality standards. Only with these can they guarantee that cars operate safely under all conditions. This also means that the way in which products are designed is very strictly regulated. Every piece of hardware or every line of software code must be certified with respect to some manufacturer requirement. Your research was on how to upgrade a standard system design process such that it satisfied all the strict requirements required for automotive products. You did it very well, both practically in the sense that the process was installed, but also from a theoretical perspective on how the rest of the world implements these safety and traceability requirements. In fact, you also became a certified ASPICE assessor, which means that you are authorized to determine the level of ASPICE compliance of an organization. Because you did a double electrical engineering embedded systems degree, you had to deal not with double the paperwork, but 4 times. You had to write a technical report for ES, embedded system, a paper for electrical engineering, as well as a confidential report for ES. And it wasn't always clear what to fill in on what graduation form. Anyway, the most important thing is that you delivered a good graduation project and got your 2 degrees. So congratulations again, and I wish you all the best in your future career. Okay, so I didn't know that. Apparently you have cum laude, right?
Yes, that's a special thing.
Okay, so I congratulate you for having cum laude.
Yeah.
What happened? So, it goes down again.
It's a technical university.
Okay. Dear Vargov, you were supervised by Professor Kees Goossens, and congratulations with your degree on behalf of Kees. Last year, you asked me if I was willing to supervise your project at Punch Powertrain in Eindhoven. The topic was performance-aware multi-rate scheduling design for real-time control systems. The topic was interesting and close to some of our research on embedded control. Moreover, I didn't really know Punch Powertrain, so this was a good opportunity to learn more about them. Punch Powertrain make transmission for cars, in particular dual clutch transmission. Normally, when you change gear in your car, the engine first decouples from the wheels. You change gear, and then you recouple. This means a loss of power, but you also feel the gear shift, which is uncomfortable. In dual clutch transmission, the 2 gears are essentially both active at the same time, and the changeover from one to next can be continuous. This results in a continuous transfer of power and avoids abrupt change. Now, as most of you are aware, nothing really works without embedded systems or embedded electronics anymore, and transmission are no exception. So the changeover from one gear to the next is managed by a complex control algorithm that is implemented as embedded software running on a computer that is dedicated to the powertrain. The aim of your project was to analyze and optimize the control algorithm such that it runs more efficiently on the embedded computer called ECU. This is a complex job because almost always a controller is designed without regard for its final implementation. Control engineers design the best possible control algorithm, which is therefore often very complex. Afterwards, the embedded software designers have to see how to run the control algorithm on an ECU that has only limited resources, such as processor, speed, and memory. Complex trade-offs between quality of control and the cost of the final system are the result. You analyze the control algorithms in terms of hierarchy and number of tasks, their execution time, and the priorities that they require to run in the implementation. This was resulted in better trade-off. For example, a better controller that was also cheaper. More importantly, however, is that your investigation resulted in guidelines on how to design and structure embedded controllers in a better way such that they can be implemented more reliably and efficiently. You did this in a structured and efficient manner, which was definitely required given the very complex controller. As an example, the controller model was so large and complex that it was not possible to safely make changes by hand. You therefore automated the restructuring of the model, and this also led to a new guidelines for the models. So congratulations again, and I wish you all the best in your future career. First need to find my... Okay. Dear Arun, I'm very happy that to see you here again. And congratulations, and nice to see you. So I have the honor to hand in the degree of Masters of Embedded System Program. You started your master project on exactly 1st of February 2019 at IRDITO in Eindhoven, working on multi-protocol device commissioning framework for Internet of Things mesh networks. The problem that you targeted to solve was that different wireless mesh technologies may be used at the same place by different devices. For example, at a home or so. These technology standards have their own method of provisioning nodes when you want to add a new device to the network, or when you want to remove a device from the network. From the user's point of view, it is not a good experience, since they have to follow different procedures mandated by different technologies. Then you studied in detail the commissioning procedures of 3 different widely used technologies, Zigbee, Thread, and Bluetooth Low Energy, and designed a common framework which makes just a single unified procedure for user to do commissioning, to add nodes or remove nodes from the network. It was a quite tough assignment, considering the complications and details of different technologies that you needed to tackle. But you did it very well. Actually, you had a problem that your duration, your master project duration, was a bit shorter than the regular master students, because you didn't have that 2 months preparation period. But at the end, you achieved the goals, which showed your hardworking commitment and enthusiasm. You were very organized and polite, which made it very enjoyable for me to work with you. By the way, you were lucky in the sense that the company closed the Eindhoven branch that they had right after you finished your project. It was not your fault, but the plan that they had. So again, I would like to congratulate you for this achievement, and I wish you the best in your life and in your future career. Dear Mike, today I have the honor to give you the master's degree of the Embedded Systems program. In the beginning of this year, after you had the Networked Embedded System course with me, you showed your interest in doing your master project in the embedded networking domain. So we offered you a project at the Electronic Systems Group on modeling the coexistence of co-located Bluetooth Low Energy and time-slotted channel hopping networks. Bluetooth Low Energy is a widely used wireless technology present in almost any smart mobile, tablet, and personal computers nowadays. On the other hand, TISH, or time-slotted channel hopping, provides a reliable communication, mainly for industrial applications. Both standards use channel hopping, but in the same frequency band. So we were interested to understand the impact of these two technologies on each other when they are co-located in the same environment. So I remember that just 1 week after you were done with your preparation work, after your preparation presentation, you came up with the whole detailed model implemented in MATLAB, which was really impressive and unexpected, since I was not even sure if you know what exactly is expected as the model. And after that, you did a lot of simulation with your model, but it was not the end. You also implemented and experimentally verified your model with real hardware. 2 different hardware, 2 different protocol stack, Bluetooth Low Energy and TISH, and it really needed quite some work. And that actually needed a very good embedded programming and development skills. So the result of your thesis is greatly appreciated in our group. So you were very organized, committed, and always appreciated our feedback. So it was a very nice collaboration indeed, and I would like to congratulate you again for this achievement and wish you the best in your life and in your future career.
Dear Pega, I have to apologize that I'm giving this speech rather than Dr. Raslebi, Taner Raslebi. He couldn't make it, so he asked me to give this speech for you. So when I say I mean it should be Taner. First of all, I would like to apologize for not being here personally to give this speech due to conflicting obligations. It has been a pleasure working with you for reasons that will become apparent in a minute. Last year, Irgetto had several projects that they shared with us, in which they wanted to investigate IoT mesh networks management. Luckily for us, you applied and you had an interview at Irgetto. They thought that you were up to the task for any of the several assignments that they had on this topic, so you got to pick. You ended up choosing the assignment on segmentation of the Bluetooth mesh and the requirements of applications. With me as your university supervisor, this brings me to this. One thing I know about you as a person is that you like a challenge. You didn't do this assignment just because you wanted a diploma, but instead you wanted to do a real good job. Irgetto had more than one project that you could choose from, but you picked a difficult assignment, knowing all along that it was difficult. This assignment was about solving a complex problem, not only from a theoretical perspective, but also from a practical perspective. Implementing such a Bluetooth mesh network and the required network segmentation for your evaluations required a lot of effort and patience. But you did it. In the process, you had great collaborations with an excellent team, especially with your company supervisors Milos and Kalin, and your university tutor, Quingzi. My most memorable anecdote about you is about the day of your final defense. On the day, in the defense room, you had a lot, and I mean a lot, of supporters who clearly cared about you. Many of them had flowers, champagne bottles and other gifts in their hands, ready to celebrate right away. This tells me how much you are loved and how much confidence everyone had in your success. By the way, the committee did not feel any pressure at all. Joking aside, you have done a brilliant job in making this project a success. As people who are involved, we enjoyed every minute of it. Your family can be very proud of your achievements here. Now you have a new adventure in front of you with your new job at EV Box in Amsterdam, and I wish you all the best in life and great success in your future career.
So I have to apologize for Wieger Wesseling, who couldn't be here due to obligations. My name is Jeroen van der Wulp. I'm the supervisor of Ruud at Sioux. And I'm going to tell you a bit about the work he did there. I clearly remember the first time when I met you, Ruud. It was in a small meeting room, and we were the three of us, right? Robert as an architect, Robert Hendriksen. He's been developing a tool in several different projects, a model-driven design tool to use models in order to express software behavior, and ultimately also to verify some properties on those models in order to have a better feeling of that the behavior of a system is correct. And that was the assignment that we had in mind for you. So you started off hearing us out, and we told you about this big model checking challenge, which was completely new for you, right? You did a couple of courses on the topic, but it was vague. You had more affinity with the model-driven aspect and the user interface aspect than with the actual model checking, but you took the challenge anyhow. And in the end, it turned out very well. Because Ruud joined us at Sioux, and he managed to complete the work that he did during this graduation assignment and bringing it to a new level. So it's actually being used at the moment in a real-life project, or about to be used in real-life projects, but it's still a new release. So in that respect, it was a very successful project for you. And all the more difficult, have some aspects of the theory behind it, the theoretical foundation. They were not really your strong suit. And then, to make matters worse, I fell ill and couldn't supervise you. So a number of other supervisors stood in, and you were dragged in different directions. You know about multiple captains on one ship, right? It doesn't really work out that way. You don't have a straight course. So in the end, you managed to overcome all of this, and still produce a nice bit of work that we can use every day. Ruud, I wish you the best in life and in the rest of your career.
Dear young engineer Joshi, dear Chandrika, congratulations with passing this major milestone, a master in embedded systems at the TUE. To be more specific, you followed the EIT master program together with your husband, Barkav Kinnan, who received his diploma a couple of minutes ago, and you both did your first year in Berlin. It's exceptional that a couple receives their diploma in the same event. You have performed your master's assignment at Van der Lande in Veghel, where Eric Dartel and Jasper Meens were your daily supervisors. Van der Lande produces systems for parcel handling and airport baggage handling, amongst others, and you focused on sorter systems. The aim of your work was to emulate a specific controller, the STM32F407, enabling design and testing using a laptop rather than the actual hardware board. You worked very independently, identifying how to address the problem and what to use. Using QMU, the selected emulator for the implementation of the controller, turned out to be very demanding, however. Although the quantity of your work was rather limited due to the complexity of QMU, your results are coherent and of good quality. Van der Lande is therefore happy with your work, and so are we. Dear Chandrika, I would like to congratulate you once again with your master, also on behalf of Richard Verhoeven, who was your co-supervisor at the Technical University in Eindhoven, and wish you all the best in your career.
Dear Sinduya, in October last year we got in touch through Bas Lutek, who's the program coordinator of the Embedded Systems Master Program that you just completed here today. You found an interesting assignment at Philips Research, but you are still looking for a supervisor who would be willing to supervise this project. And this is how we got to know one another. Within this project, you would be working on intellectual property protection for neural networks. Neural networks are rapidly becoming the most dominant means to build intelligent systems. All kinds of devices like self-driving cars, smart homes and healthcare systems to detect, for example, cancer all rely on this future technology. The companies who build these systems obviously want to protect their investments. They want to make sure that a competitor cannot easily steal their network and copy it into another product. And this is where your project comes in. Your task was to add a form of copyright protection that allows companies like Philips to see whether their competitor has illegally reused a network built, in this case, by Philips. Under the supervision of Sauri Jan and myself, you started developing and implementing initial solutions to solve this very challenging problem. Throughout the project, you also always kept us very well informed on your progress. You showed to be very independent when implementing the actual solution in an embedded platform. Essentially, without any help, you managed to translate the initial idea into a fully working prototype. And all of this was done nicely within the planning that you made. With your punctuality and excellent implementation skills, you managed to complete this project successfully. I'm convinced that with your independent way of working and your dedication, you will be able to solve many more difficult problems in the years to come. Also, on behalf of Sauri, I wish you all the best in the next step of your career, and I would like to congratulate you once more with the degree you just obtained.
Goed, beste Geert, of zoals ik het nu kan zeggen, beste ingenieur Linders. Van harte gefeliciteerd met het behalen van de titel Master of Science. Nou, het heeft een tijdje geduurd voordat je hier stond. In mijn archief zag ik dat je al eind 2017 contact gezocht had voor het voorbereiden van een masteropdracht. In eerste instantie via professor Corporaal. En uiteindelijk ben je daar ook bij mij terechtgekomen om aan een opdracht te beginnen. Nou, als ik kijk naar die eerste e-mail die ik van jou gehad heb, dan zie je daarin eigenlijk al dat jij een goede dosis daadkracht bezit. Je bent altijd lekker direct en duidelijk in wat er de doelstelling is van wat er moet gebeuren. Nou, je project speelde rond onze coarse grain reconfigurable architecture, zoals dat heet. Het is een processor De meeste van het publiek zullen het waarschijnlijk niet volgen. Maar het is een processorarchitectuur die gemaakt is om zo efficiënt mogelijk gebruikt te kunnen worden voor specifieke toepassingen. Dat betekent dat hij heel flexibel gemaakt is en daarmee dus heel getuned kan toegepast worden voor de doelstelling waar die voor nodig was. Al die flexibiliteit echter maakt het moeilijk om te programmeren. En daar was dan ook jouw opdracht in te vinden. In de jaren voordat jij begonnen was, hebben we al gewerkt aan een compiler, zodat we van een hogere taal een programma konden schrijven en daar code voor konden genereren. Maar er zijn allerlei mogelijkheden die die compiler nog niet kon. En één daarvan is vectorisatie. Dus het rekenen met getallen een heleboel tegelijk. Want deze parallelisme kan voor veel energiewinst zorgen. Nou, je hebt je daar getoond dat je alle lagen van deze complexiteit inderdaad goed wist te handhaven. Zowel in de hardware als in de software, als in de algoritmes die in de compiler plaatsvinden. Op allerlei plaatsen heb je dingen weten te fixen. En dat is bijzonder goed afgelopen met een mooie afstudeerscriptie als gevolg. Tijdens dat project heb je inderdaad ook je daadkracht en vastbesluitenheid wel weten te tonen. Je vaardigheden in de technische implementatie, maar ook je kritische blik naar de resultaten. Zowel van wat er voor jou geweest was, als wat je zelf gedaan hebt. Nou, dat heeft ertoe geleid dat je in ieder geval een aanbod gehad hebt om eventueel naar Finland te komen. Om daar verder onderzoek te gaan doen in compilers en architecturen. Maar van jou heb ik begrepen dat je eigenlijk toch wat meer je heil ziet in de industrie wellicht. Laatste keer dat we spraken was je er nog niet over uit wat en waar je dan precies wilde gaan doen. Dus hopelijk heb je daar straks meer over te vertellen intussen. In ieder geval heel erg gefeliciteerd met het behalen van deze graad. En veel succes.
Our next speaker will be Koos Vorentholt, the chair of our study association GEWIS, who will address the new Masters of Science.
Thank you, Johan. Dear ladies and gentlemen, students, family members, friends and all other attendees. Let me start with introducing myself. I'm Kees Vorentholt. I'm chairman of Study Association GEWIS, the study association for computer science and mathematics students. Today is a very special day. Today you all receive your master's degree. On this day, exactly 1 year ago, Jeffrey Herling, a Dutch motocrosser, became world champion for the first time in the MXGP. Before reaching this goal, years of training and motivation is required to get on this level. And even more energy is needed to stay on this level. In the same way, having your master's degree required a lot of studying, motivation and energy. You have worked very hard to receive this paper and degree. And this degree is only reserved for a very small percentage of the population, and you are part of this small group. At this moment, you are at the start of a whole new life, which is the time to start achieving many more goals, and who knows what someone will be telling about you in 40 years. Receiving your master's degree is something you can be proud of, but also your family, friends, and me. I'm proud of all of you in the name of GEWIS. Ladies and gentlemen, the only thing left for me is to congratulate all the people sitting here again with this wonderful achievement. That this may be only be a stimulus for the rest of your life, such that you can achieve anything that you want to achieve. Thank you very much.
Ladies and gentlemen, Masters of Science, with reference to the words of the previous speakers, and on behalf of the two departments, Mathematics and Computer Science and Electrical Engineering, I would like to congratulate you and your family and friends on your degree. I wish you every success and good fortune in your future careers. The university likes to stay in contact with its graduates. That's why we ask you to register in AlumniNet and become a member of one of our alumni organizations. And some more information is in the map that you have received today. The scientific degree of masters comes with duties as well as rights. And as a holder of this degree, you are committed to standards of scientific integrity, trustworthiness, intellectual honesty, openness, independence, and societal responsibility. These standards are described in more detail in the Netherlands Codes of Conduct for Research Integrity and in the Eindhoven Code that's derived from that. You also have duties towards society. You must be clear about the boundaries of your own knowledge and expertise, and you must communicate honestly and independently about the results of your work and all the risks associated with it. You are committed to the ethical codes for research and design involving human subjects or animals. These are serious words, and it's a serious matter, but today is a nice day. We are going to celebrate this event. We're going to close this in a few moments, but after that we would like to have a little ceremony here in the front, where we first congratulate you, all the new Masters of Science, from the people here behind the table, and I ask you then in a few seconds to line up facing the audience so that we can shake your hand. Afterwards, we will take a photograph. Somewhere over there, we will be instructed how to do so. And after that, everybody can congratulate, shake their hands, and congratulate with their achievements. There will be above. You will find drinks and little snacks for that. With that, I would like to close this meeting. Facing the audience.